So, good morning, one and all. Today's session or the lecture is for bright student activity. So, we have finalized the students, consider the students as a bright student from your class. So, they are going to present their topic. So, all of you are requested to please take this benefits advantages. They are sharing their knowledge, so if you have any difficulties regarding with this, you can ask your doubts. I am here for observing this activity and supporting us to all the students. So best luck. So I request first student, that is the Achal Shah. Please share your presentation.
Okay, ma'am. Thank you, ma'am. Is my screen visible?
Yes.
Okay. Good morning, one and all. Today, hello friends. Today I am going to explain the topic data warehouse. So let us see data warehouse. So what is the need of data warehouse? For this, I am going to explain it with one example. So everyone must be knowing about Big Bazaar. So Big Bazaar must be having many branches. So let us consider there are 7 branches of Big Bazaar. 1, 2, for here, 1, 2, 3, 4, 5, 6, 7. It is displaying the branches. So if the owner of the Big Bazaar wants to know the product or the sale of the product from each of the branches, so he will conduct that message to the manager, and the manager will collect all the information from one branches. After collecting the information from every branches, he will give to the owner. After that, if suppose owner wants now something else information like which product has been sold most. So again, the manager will go to each and every branch, give take the detailed information, and then again submit it to manager. The manager will do once to twice, but after that he will not be able to do same thing again and again by visiting each and every branch. So here the need of the data warehouse comes into the picture. The data warehouse is the place where the information can be stored from each and every branches. So whenever the owner wants anything detailed, he will directly visit to data warehouse without going to the data manager or anyone else. So this is the need of data warehouse. And from this example, we can conclude that data warehouse is a big collection of data from small databases. Now let us see what is the actual definition of data warehouse. Data warehouse is a subject-oriented, integrated, non-volatile, time-variant collection of data in support of management decisions. So what is subject-oriented? Subject-oriented, for example, this blocks, that is EPCS. In the data warehouse, this data is stored in blocks. It is not stored randomly. It is stored in the specific block. For example, sales detail will be stored in the sales block. Customer detail will be stored in the customers block. Products detail will be stored in products detail, and employees detail will be stored in one block, so that the details data will be not mismatch or mix. So it is stored in the block. So that is subject oriented. Integrated. Integrated means the data is integrated together. Data is from different forms. So it will be integrated in the same form, that is standard form. Then non-volatile. Once the data is stored in the data warehouse, it cannot be updated or changed. So that is, it is non-volatile. Time variant. Time variant means it will store the data from many of the years. Means back 5 to 10 years details we can found in data warehouse. And the collection of data in support of management decision. All this data that is stored in the data warehouse is for taking the management, it is for decision taking. From all the details, the management can take decisions whether which products we have to increase, which product has sell more, so what we have to do. Everything can be taken from the data warehouse. Next, types of data. There are two types of data, operational data and strategic information. Operational data is the one which is used in day-to-day life. For example, company labor statistics, projection of needed resources. And then strategic information. Information which is used for decision making is strategic information. And the examples are sales, production, which product is not sold. All this is nothing but the strategic information. And the data which is stored in the strategic information is nothing, the data which is stored in the data warehouse is nothing but the strategic information which will help the owner or the businessman to take the decisions. And the different names of data warehouse are decision support system, executive information system, management information system, business intelligence solutions, analytical applications, and data warehouse, which we already know. These are the different names of the data warehouse. Then the types of data warehouse. There are mainly three types of data warehouse: enterprise data warehouse, operational data warehouse, and data mart. So enterprise data warehouse is a centralized warehouse. It provides decision support service across the enterprise. It offers a unified approach for organizing and representing data. It also provides the ability to classify data according to the subject and give access according to those divisions. Enterprise data warehouse is the centralized data warehouse. Operational data store. Operational data store, which is also called ODS, are nothing but data store required when neither data warehouse nor OLTP system supports organization reporting needs. In ODS, data warehouse is refreshed in real time, hence it is widely preferred for routine activities like storing records of the employees. And third, data mart. A data mart is a subset of the data warehouse. It's specially designed for a particular line of business, such as sales of finance. In an independent data mart, data can collect directly from sources. So these are the types of data warehouse, which are enterprise data warehouse, operational data store, and data mart. Then the elements of data warehouse. The elements of data warehouse are a relational database to store and manage data, and extraction, loading, and transformation, that is ELT, solutions for preparing the data for analysis, statistical analysis, reporting and data mining capabilities, client analysis tool for visualizing and presenting data to business users, other more sophisticated analytical applications that generate actionable. These are the elements of the data warehouse. Then overlook of architecture of data warehouse. So it consists of data sources, staging area, data warehouse, data mart, and then user. So data sources, these are the sources from where data is coming. So staging area. In the staging area, the data is cleaned and then it is transferred to the warehouse where metadata, summary data, and raw data is there. In metadata, we will get the data of the data, means where the data is stored, which data is stored, everything we will get in the metadata. In summary data, we will get the summarized data of the data, and in the raw data, we will get the raw data. Then data marts. In data marts, it is divided into the specific group. For example, for marketing people will get all the details in data mart, that is, it will consist of sales, products, everything will be in one data mart. For example, your purchasing data mart will consist all the details about the purchasing, sales, and inventory. And then it is used by the user. So user can directly go to that data mart whichever they require. No need to visit each and every data. This is all about the architecture of data warehouse. Now the advantages of data warehouse. Data warehouse allows business users to quick access critical data from same source all in one place. Then second, data warehouse helps to integrate many sources of data to reduce stress on the production system. Data warehouse helps to reduce total turnaround time for analysis and reporting. Restructuring and integration makes it easier for the user to use for reporting and analysis. Data warehouse allows users to access critical data from the number of sources in a single place. Therefore, it saves user time of retrieving data from multiple sources. Data warehouse stores a large amount of historical data. This helps users to analyze different time periods and train to make future predictions. These are the advantages of data warehouse. Then disadvantages of data warehouse are creation and implementation of data warehouse is surely time consuming affair. Then data warehouse can be outdated relatively quickly, difficult to make changes in data types and ranges, data source schema, indexes, and queries. The data warehouse may seem easy, but actually it is too complex for the average user. Despite best efforts at project management, data warehouse projects cost will always increase. Sometimes warehouse users will develop different business rules. Organization needs to spend lots of their resources for training and implementation purpose. These are some of the tools which we can use for data warehouse. It is MarkLogic, Oracle, and Amazon Redshift. It is all. Thank you.
Very good. Chal.
Thank you, ma'am.
Any questions from student side? Any questions? Do you want to ask something to Achal? See, she is your friend. Don't hesitate. This is not the lectures, regular lectures. This is one activity. You can share your thoughts, your views. You can ask your doubt. So don't have any doubts. Then we will go forward. Next student is the Meghna Verma. Please share your screen and start your presentation.
Yes, ma'am. Sure. Hello. I hope I'm audible and my screen is visible.
Yes.
Okay. So good morning, everyone. Today we are going to discuss about the architecture of data warehouse. So actually, I've already discussed what is data warehouse. We are just going to look about its architecture in detail. So a typical data warehouse system consists of the 8 layers. The first one is data source layer, extraction layer, staging area, data storage layer, data presentation layer, ETL layer, data logic layer, and metadata layer. So here is the overall architecture of data warehouse. This right here is the data source layer. So the data source layer usually contains the relational databases, ERP system, purchase data, and legacy data. So there are many different types of data which are stored in the data source layer. Now there can be operational data like product data or inventory data, then web server logs with user browsing data, the data of internal market research, and third-party data such as census or survey information. When these all data comes together, it forms a data source layer. The next is the data extraction layer. So in the extraction layer, the data is extracted from the source layer and then it is given to the data warehouse. So first of all, the data extraction cleansing. Here the data which is extracted is a data cleansing is performed on that, not major transformation is done. And after that, the data is given into the staging area. The staging area is used to store the data, and after that, the data is given to the data warehouse. So the staging area is basically required because in staging area, many types of data are present. So it is a common area for all the data, and due to which the data processing and integration becomes easier. So next comes the ETL layer, or data loader. So ETL is nothing but extraction, transform, and load. We'll see about this in the next slide. And then data storage layer. In the data storage layer, now depending upon the functionality and scope of the system, there are three major components present in the data storage layer: data warehouse, data mart, and ODS, that is operational data store. Then the next layer is the data logic layer. In the data logic layer, all the business rules are kept, and these rules does not affect in any way the rules of the transformation. And the next layer is the presentation layer. Now this layer is the interface for the end user interaction. Here the user can see all the data which are available for them. The format may be tabular or graphical report, or it can be also an email report which gets automatically generated and it is sent to the presentation layer. And in this layer, OLAP tool or online analytical processing tools are also used. The last layer in the architecture is the metadata repository or metadata layer. So a metadata layer is said as the data for the data. It means the data which is present in the data warehouse, the information about that particular data is stored in the metadata layer. So next is the ETL layer. So as I have already told, that ETL is extraction, transform, and load. So in the ETL layer, it collects the data from the external source. The data is transformed into a specified format, and then it is loaded into the data warehouse. Now, as we can see in the diagram, that some data sources are present. We perform an ETL operation on that, and then the data is brought into the staging area. After that, performing some ETL operation, the data is stored into the warehouse, and then these are the data marts in which the data is stored from warehouse to the data marts after performing some ETL operations. Now, right from the beginning, when the data is brought from the source to the staging area, there the extraction is performed. And then further, the transformation of data is performed, and then while bringing the data from warehouse to data mart, some loading is performed. We'll see the definition of extraction, transformation, and loading. So the extraction it involves connecting to the source system and both selecting and collecting the necessary data needed for analytical processing. So first of all, we have to connect to the source system. And after that, we have to select the necessary data and then collect the required data for the further processing. Now, many a times, the integrity problem may arise in the extraction phase. Now, integrity problems means there may be two data with different name but the same meaning. Now, for example, the BTech degree and BE degree, they both usually means the same, but the name is different. So in that case, the integrity problem may occur. The next is the transformation. So it is nothing but a series of steps that are performed on extracted data to convert into the standard format. So a format is already specified, and only the data which is extracted, it is converted into that specified format through a series of steps. And the last is loading. In loading, it imports the transformed data into a large database or warehouse. The next topic is conceptual models of data warehouse. So in data warehouse, schemas are designed for data analysis with the help of OLAP, that is online analytical processing tools. Now this data which is stored, it is generally of two-dimensional data which has the attributes like measure and dimension. And a table which stores this data is known as fact tables. Now these tables are usually very large in size. There are three types of schemas available in data warehouse, that is star schema, snowflake schema, and fact constellation schema. So first one is the star schema. In this schema, it contains of fact tables and there are multiple dimension tables available. And the foreign key, there are the foreign keys from fact tables to the dimension tables. We'll see an example of the information about the sales of a retail store. Here you can see that this sales table is a fact table, and it contains the dimension like item ID, store ID, customer ID, and date, whereas number and price are the measure. So here the dimension acts as the foreign key to the other table. Now this other table is called as dimension table. So here we can see that item ID is the foreign key for the item info table, which is a dimension table. Similarly, store ID, for store ID we have store dimension table. For customer ID we have customer dimension table, and for date we have date info dimension table. So as the representation of this is like a star, so hence the name as star schema. Now the advantages of star schema is that it is very simple and easy to design. It optimizes navigation in the database, and it is very much suitable for query processing. The disadvantages is that it is not very much flexible in terms of analytical needs as a normalized data model. The next one is the snowflake schema. In snowflake schema, the dimension table is further normalized and split up into a multiple tables. Now we'll understand this with the help of an example. Here the same example is present as we have seen in the last slide. Here a sales table is present, and these are the dimensions, which is date, customer number, product number, and city name. So these are the dimension table. For date we have time, for customer number we have customer as the dimension table, then for product number we have product, and for city name we have city as the dimension table. Here we can see that the region is, the city is split up in another dimension table, that is region. So here we have the multiple dimension table. The advantage of this snowflake schema is that it has less redundancy due to normalized dimension table, and the dimension tables are easier to update. The disadvantages faces are we require complex queries for the schema, and the number of joins also increases. The last type of schema is the fact constellation schema. So this fact constellation schema is also known as galaxy schema. It consists of multiple fact tables, and here many different fact tables can share the same dimension table. Now we'll see this with the help of an example. Here the booking and checkout is a fact table, and hotels, travel agents, customer, room type, and promotion are the dimension table. So here we can see that booking and checkout shares the dimension table of hotel, customer, and also the room type. So this is the fact constellation schema. The advantages of this schema is that it provides a flexible schema, and the disadvantage is that it becomes very complex due to multiple fact tables which are present, and due to that it also becomes difficult to manage, and the dimension tables are very large in this case. The last topic is the data mart. So the data mart is the access layer of the data warehouse environment that is used to get the data out to the user. So data mart, it acts as a subset of data warehouse, and it is usually oriented to a specific business line or team. Now the data warehouse, it consists of the information of large information. On the other hand, the data mart, it pertains to a single department of information. Now the main reason why the data mart are used is because when the information is stored in the data warehouse, it is not very organized, due to which the data is not very organized, and because of that, the query which we use to access the data, it also becomes complicated, and it is very resource consuming. And the data warehouse are also designed to access large group of related records. But the data mart, they have access to a specific type of data, so due to which it improves the end user response time, and so the processing power also increases by using the data mart. So we can say that a data mart is basically a condensed and more focused version of data warehouse that reflects that reflects the regulations and process specification of each business unit within an organization. So that was all. Thank you.
Very good, Meghna. Well done. Nice
Thank you,
presentation,
ma'am.
nice collection. So anybody, any doubt, any questions? Anybody want to ask something to Meghna? Okay. So third the student is the Bhanudas Rane. I request to Rane, please start your presentation.
Yes, ma'am. My screen is visible to all and I am audible to all.
Yes.
Yes, yes.
Hello, friends. Today's our topic for DBMS presentation is cloud database. And in this presentation, I will discuss about cloud databases. So let's discuss about. So what is cloud database? A cloud database is a collection of content which may be structured that resides on a private, public, or hybrid cloud computing infrastructure platform. So in this definition, the collection of content. Collection of content means collection of data which may be structured or unstructured. Structured database that we'll see in next upcoming slides. Structure means contain the rows and columns. And best example is structured database is MySQL or PostgreSQL, or unstructured database is the database that collection of documents, and it is NoSQL database that resides on a private, public, or hybrid cloud computing infrastructure platform. So infrastructure platform related to the cloud computing. As you know, cloud computing is divided into three: infrastructure as a service, platform as a service, and software as a service. So in cloud database is related to the infrastructure as a service. Second point is cloud database typically run on cloud computing platform. So next is cloud computing. Cloud computing is the delivery of different services through the internet, including data storage, servers, databases, networking, and software. So cloud computing is basically run on the internet. So in second point, cloud-based storage makes it possible to save files to a remote database and retrieve them on demand. In a right-hand side image, we can see that the if any uh, any virus or any uh, any data is missed in one device, then it is retrieved from the other devices also, because it is used in one cloud, and different devices is connected to the one cloud. So this is the best advantage of cloud computing. Next is in this left hand side image, you can see that cloud computing provided us First, public and hybrid cloud. Private cloud means using a cloud infrastructure only by one customer organization having the access, and it is not shared with another other. This is the private cloud, and many companies have this private cloud purpose, security of database and R&D work. All these are require private cloud. Then so what in another layer is located on the
Excuse
premise means
Rani,
uh,
Bhanudas Rani, your voice is not clear.
public.
Bhanudas, hello, am I audible to you? Your voice is breaking.
Hello. Yes, ma'am.
Yes, your voice is breaking.
Ma'am, I'm audible to
The
you.
proper range. It may be possible there is the range issue.
Hello.
So come into the proper place. So you will get the proper range, and your voice will be good. Means it will not break. So come into the
Yes, ma'am.
right place where you will get a proper range.
Ma'am, I'm
Yes,
audible to you
yes.
clearly. Yes. Yes. So we will discuss this point. Public cloud. So, what is public cloud? Public cloud is the cloud computing infrastructure is located on the premises of the company that offers the services, and in the company email or customer relational management and other business support application on the public cloud. This is all having the access of public cloud. Then hybrid cloud. So hybrid cloud means it is the combination of both private and public cloud based on purposes and requirements. So hybrid cloud means deploy app on private cloud and access due to the public. Means which public having the access of that database or any app that will be decided by administration. This is the hybrid cloud, and it is provided by one of the uh, most industry means IBM is provided these services. In right hand side image, you can see that first four devices is connected to the cloud. First computer send to the data to the cloud. So it is also the advantage of cloud. In next slide, advantage of cloud computing. Cloud computing having the following advantages. First is lower computer cost, means customer who buy the service has no need to storage and computer service provider having this facility. We are only use this. Second is improve performance, then reduce software cost, instant software updates, then improve document format compatibility, then unlimited storage capacity. You only the pay for this service and you can get unlimited storage capacity. Then increase data reliability, universal document access, then latest version availability. You can means service provider update software and you can use latest version of that software. And next is easier group collaboration and device independence. Means it is not depend on any device, it is independent to each other. This is the all the advantages of cloud computing. Next is the deployment models. So we can move to the database as a service, that our main topic. There are two primary ways to run a database in a cloud. First is a virtual machine image. This is the also called as traditional method. And second is database as a service. So next, virtual machine image. In this model, the database runs on infrastructure of IT department through a virtual machine. Cloud performance cloud platforms allows users to purchase virtual machine instances for a limited time. Then managing the database is responsibility of IT staff of the organization. Users can upload their virtual machine image or use ready-made machine images. Means in virtual machine images only in virtual machine images the responsibility of IT staff that managing the database and all the virtual machine related management. And next, database as a service. This is the paid service given to the cloud computing platform. So database as a service is a cloud computing service model that provides users with some form of access to a database without the need for setting up physical infrastructure, installing software or configuring for performance. There are different types of service levels available. So there are two levels of service. First is classic database as a service arrangement, and second is managed hosting arrangement. So in this the two levels. So next we can see service levels. So first is classic database as a service arrangement. In this, physical infrastructure and database is managed by the provider, while the contents and operation of database are handled by the customer. So in this classic database as a service arrangement, all the work related to the database and operation are handled by the customer, and also it is our decision to manage the database. And second, the managed hosting arrangement. In this, everything including database, maintains and manage is handled by the provider. Means provider having the access to manage the all the your database and operations. Next, cloud database architecture. So cloud databases are divided into two broad categories. First is relational databases and second is non-relational databases. So relational databases, as you know, it is written in SQL, structured query language. Second, it is contains set of tables with interrelated to each other, means tables in the columns and rows form. And third is the schema specified in the relational database is the relationship between the tables. And second is non-relationship database. It is non-relational database means do not support to the table format. Second is data is stored in single document and it is unstructured data. Relational database is the structured database means it is a stored in tables, and non-relational database is the unstructured database. It is stored in the documents files. Next is SQL data model examples. So when we if you your project if you use deployment method as a virtual machine deployment, then three database is available. First is EDB Postgres Advanced Server, second is IBM DB2, and third is MySQL. And if you use the database as a service, then first is Amazon Relational Database Service, then Clustrix Database as a Service, then third is Google Cloud SQL. This is the three database used when we use the SQL data model in database as a service deployment method. And if we use NoSQL data model, then in virtual machine deployment, three database available: Apache Cassandra, then second is Cluster Point Database VirtualBox, and a third is CosDB. And if we use the NoSQL database with database as a service deployment method, then first is Amazon DynamoDB, second is Azure Document DB, and third is Google Cloud Bigtable. These the three database NoSQL database are available to us. So thank you. This is from my side.
Very good. A nice presentation, Bhanudar. Anybody else from any questions from
Thank you, ma'am.
side? See, this is only not the activity. This is through this activity you achieve your uh, delivery presentations skill, like how to deliver the contents, how to prepare the PPT, that kind of things developed in your side, because this is very essential things. Your marks always does not comfortable. Your presentation skill, communication skill is very important, and that kind of the activity helps you to give the build up your confidence. Okay, so third student is Akde. Vaibhav Akde. Vaibhav Akde, are you there?
No, ma'am, he's not in the meet.
Okay, Vaibhav Akde is not there. Okay, Sohab Deshpande.
Yes, ma'am.
So please start.
Is my screen visible?
Yes, it is visible.
Okay, so good morning, everyone. My topic for today's presentation is data replication. It is considered very important in database management system. So let us learn what is data replication, why is data replication important, replication schemes, types of data replication, and their respective advantages and disadvantages. Data replication is the process of storing data in more than one site or node. It is useful in improving the availability of data. It is simply copying data from a database from one server to another server so that all the users can share the same data without any inconsistency. The result is a distributed database in which users can access data relevant to their tasks without interfering with the work of others. Data replication encompasses duplication of transactions on an ongoing basis so that the replicate is in a consistently updated state and synchronized with the source. However, in data replication, data is available at different locations, but a particular relation has to reside at only one location. There can be full replication in which the whole database is stored at every site. There can also be partial replication in which some frequently used fragment of database are replicated and others are not replicated. Types of data replications. Transactional replication. In transactional replication, users receive full initial copies of database and then receive updates as data changes. Data is copied in real time from the publisher to the receiving database, or we can say as subscriber, in the same order as they occur with the publisher. Therefore, in this type of replication, transactional consistency is guaranteed. Transactional replication is typically used in server-to-server environments. It does not simply copy the data changes, but rather consistently and accurately replicates each change. The second is snapshot replication. Snapshot replication distributes the data exactly as it appears at a specific moment in time, does not monitor for updates to the data. The entire snapshot is generated and sent to users. Snapshot replication is generally used when data changes are infrequent. It is better. It is a bit slower than transactional because on each attempt it moves multiple records from one end to the other end. Snapshot replication is a good way to perform initial synchronization between the publisher and the subscriber. The third is merge replication. Data from two or more databases is combined into a single database. Merge replication is the most complex type of replication because it allows both publisher and subscriber to independently make changes to the database. Merge replication is typically used in server to client environments. It allows changes to be sent from one publisher to multiple subscribers. Replication schemes. There are three replication schemes: full replication, no replication, and partial replication. Full replication. The most extreme case is replication of the whole database at every site in the distributed system. This will improve the availability of system because the system can continue to operate as long as at least one site is up. Advantages and disadvantages. Uh, its advantages are: it is a high availability of data. It improves the performance for retrieval of global queries, as the result can be combined locally from any of the local site. It is faster execution of queries. The disadvantages: concurrency is difficult to achieve in full replication. Slow update process, as a single update must be performed at different databases to keep the copies consistent. The second is no replication. The other case of replication involves having no replication, that is, each fragment is stored at only one site. The advantages are the data can be easily recovered and concurrency can be achieved in no replication. The disadvantages: since multiple users are accessing the same server, it may slow down the execution of queries. The data is not easily available as there is no replication. And the third, it is partial replication. In this type of replication, some fragments of database may be replicated, whereas others may not. The number of copies of fragment may range from 1 to the total number of sites in the distributed system. The description of replication of fragments is sometimes called the replication schema. Its advantages is that the number of copies of fragments depends upon the importance of data. Advantages of data replication. So data replication is generally performed to provide a consistent copy of data across all the database nodes. To increase the availability of data, the reliability of data is increased through data replication. Data replication supports multiple users and give high performance. To remove any data redundancy, the databases are merged and slave databases are updated with outdated or incomplete data. Since replicas are created, there are chances that the data is found itself where the transaction is executed, which reduces the data movement. To perform faster execution of queries. And the disadvantages of data replication: more storage space is needed, as storing the replicas of same data at different sites consumes more space. Data replication becomes expensive when the replicas at all different sites need to be updated. And the last, maintaining data consistency at all different sites involves complex pages. Thank you.
Very good, Soham. Nice presentation. So, anybody, any questions? Do you want to ask something to Soham? Okay, so next student is the Agam Shah. Agam Shah, are you there?
Yes, ma'am.
What is your topic?
Ma'am, introduction to HBase.
Introduction to HBase.
HBase.
Okay, let's start.
Ma'am, am I audible and my screen is visible?
Yes.
Hello.
Yes.
Uh, Hello everyone. My name is Agam Shah and my topic is introduction to HBase. So these are the contents of this topic. So first is, what is HBase? HBase, the part of Hadoop's ecosystem, limitations, features, HBase versus HDFS, HBase data model and logical view, HBase keys and columns, HBase physical model, HBase architecture, zookeeper, and conclusion. So first topic is, what is HBase? So HBase is nothing but the open source non-relational distributed column-oriented database modeled after Google's Big Table. Google's Big Table is nothing but a compressed high-performance data storage system built on Google file system. So HBase is the database which is used to store huge amount of data in a random manner. HBase is an Apache open source project whose goal is to provide large storage for the Hadoop distributed computing. So data is logically organized into tables, rows, and columns. So HBase the part of Hadoop's ecosystem. So as you can see, HBase is built on the top of the Hadoop distributed file system, and these HBase files are internally stored in HDFS. So there should be some of the limitations of Hadoop. So we are using this HBase. So the limitations of Hadoop are issue with small files, slow processing speed, support for batch processing, no real-time data processing, no delta iteration, latency, not easy to use, and security. So what are the advantages of HBase and features? So HBase provides us the linear scalability capable of storing hundreds of terabytes of data, that is the 1000 GBs of data, automatic and configurable sharding of tables. So sharding is the process of breaking up large tables into smaller chunks called shards that are spread across multiple servers. A shard is essentially a horizontal data partition that contains a subset of the total dataset. So the next is automatic failover support, which is provided in HBase and not in Hadoop file system. Strictly consistent reads and writes. It also integrates nicely with Hadoop MapReduce, both as source and destination. So first we will see what is MapReduce. MapReduce is a processing technique. MapReduce is a processing technique and a program model for a distributed computing based on Java. So the MapReduce algorithm contains two important tasks, namely map and reduce. So the map takes a set of data and converts it into another set of data where individual elements are broken down into tuples. Secondly, reduce task, which takes the output from a map as an input and combines those data tuples into a smaller set of tuples. So this is the main functioning of MapReduce to
Hello, Agam.
yes,
Your screen is not visible.
yes, wait a minute. Is my screen visible now?
Yes, your screen is.
Yes, it is visible now.
So yes, this was the main functioning of MapReduce to take the data and convert it into the smaller set of data. Next is Easy Java API for client access, that is application programming interface, Thrift Gateway and REST APIs, bulk import of large amount of data replication across clusters and backup options, which is the limitation of Hadoop, that it does not provide the backup options. It also blocks cache and Bloom filters for real-time queries and many more. So what is the difference between HBase and HDFS? That is the Hadoop distributed file system. So both are distributed systems that scale to hundreds or thousands of nodes. HDFS is good for batch processing, scans over big files. Not good for record lookup, not good for incremental addition of small batches, and also not good for updates. Now we will see the HBase features. So HBase is designed to efficiently address the above points. It provides us the fast record lookup, support for record level insertion, and the support for updates. So HBase updates are done by creating new versions of values. So next is HBase data model and its logical view. So HBase data model generally consists of row keys, column families, version data, and view. So these are the some key points. So row keys uninterpreted byte arrays. Column grouped in column families. Column families defined statically upon table creation. The cell is uninterpreted byte array and a timestamp. Timestamp is nothing but the version. HBase is based on Google's big table model, that is the key value pairs. So this is the logical view. Here we see the row key, that is every row consists of the row key, that is different types of data, implicit primary key in RDBMS terms. In data section, we will see all the data is in the byte array as we have discussed earlier, and every data is separated into different column families, that is info, that is height, 9 feet, state, and CA, that is the different column families. And uh, here below we will see the different rows may have different sets of columns, that is table is sparse, that is the table is distributed. And then the single cell might have different values at different timestamp. That means it may have different versions in a single cell. So these are the keys and column families. So here we can see the each row is associated key. That is, each row has a row key. Then each record is divided into column families. That is personal data and demographic. These are the column families, and each column family consists of one or more columns. That is column under column. That is the nested column. Uh, Here these are consisted in column families. So these are the main points in data model, that is the key, column family, and column. So key is nothing but the byte array, serves as the primary key for the table and index for fast lookup. Column family has a name, that is the string variable, and contains one or more related columns. That is, as we have seen earlier, column family may contain one or more columns under one column family. Next is column belongs to one column family included inside the row, that is family name and column name as shown in the image at the side. So here is the column family named contents and the column family named anchor. So this anchor contains one or more column in the one column family, and this content column family contain only one table. Next is version number, that is the also known as timestamp. So version number is the unique within each key. By default, system's timestamp data type is long. It uses the long variable as a data type for the timestamp. And the next is value, that is also known as cell, and it is represented by byte array. So next is the physical model. Each column family is stored in separate file called H tables. Key and version numbers are replicated with each column family, and empty cells are not stored. So HBase maintains a multi-level index on values, that is key, column family, column name, and timestamp, as you can see in right hand side picture. So there is a row key, timestamp, and column family in the HBase table, and every column family has its own H tables. So next is column families. So column families has different sets of columns, may have different properties and access patterns. So column families are stored separately on disk to access one without using input output of the other. Configurable by column family, that is compression, version retention policies, and cache properties. Next is edge-based regions. Each edge table column family is partitioned horizontally into regions, and these regions are a counterpart to the Hadoop distributed file system blocks. So here we can see the every row row is the edge-based regions, and there can be numerous edge-based regions in a table, and these are represented by the row key and the edge-based regions. Now we'll see the edge-based architecture. So edge-based architecture generally consists of three major components. The one first one is the edge-based master, second one is edge region server, and third one is edge-based client. So edge-based master consists of one master. The edge region server consists of many region servers. So this in the right hand side picture we see the one master that is distributed to many region servers. So what are the components of architecture? That is the master. It is responsible for coordinating the slaves, that is the region server. It assigns regions, detects failures and admin functions. Second one is region server, that is the many slave, that is coordinated by the master, that is the single master computer. So the region server manages data regions. It serves data for read and write. And third one is region. It is the subset of tables rows like horizontal range partitioning, and it is automatically done by the region server. So the next one is Zookeeper. So Zookeeper is an open source project. It provides services like naming, providing distributed synchronization, maintaining configuration information, etc. There are temporary nodes in Zookeeper which represent different region servers. The server failure or network partition can also be tracked by these nodes, and these nodes are the Zookeeper nodes which represents the different region server. It helps to set connection between clients and region. So in this image, we can see the Zookeeper cluster, which is associated with the different region server, and the master is also associated with Zookeeper cluster. And this all comes under the HDFS, that is Hadoop Distributed File System. So the next topic is when to use HBase. So when you need random read, random write, or both, but not neither, so you should use HBase in this case. You need to do many thousands of operations per second on multiple TB of data. That is the terabyte of data. Your access pattern are well known and simple. Real-time analytics, OLAP, real-time counters, interactive reports showing trends, breakdowns, etc., and time series database. So what is the conclusion of using the HBase? So HBase is one of the most successful growing technologies of cloud computing. It have opened the window for further researching many fields. Whenever we need scalability, then the properties and flexibility of HBase can relieve us from the headaches associated with scaling and RDBMS. Henceforth, we can conclude that it should be used for easier system management and performance improvement, and also for storing the huge amount of data. Thank you, ma'am.
Very good, Agam Shaha. So HBase is very important in the next semester. That is the your subject is there. That is the big data analysis. Okay, data science and big data analysis. In this, you have the detail regarding the HBase as well as the Hadoop. So on this basis, you have the practicals on this basis. So that times you will get how the HBase as well as the Hadoop will work. So now we will take the next student, next presentations. That is the Preeti Chintaluri. Are you there?
Yes, ma'am.
Okay, start your presentation.
Is my screen visible, ma'am? Good morning, everyone. My topic for the presentation is NoSQL database. Sometimes the term NoSQL seems to be confusing, but actually the meaning of NoSQL is not only SQL, which is also known as non-SQL or non-relational. This database is a non-relational database management system that does not require a fixed schema. As we can see in relational database, we need a schema. In NoSQL, it is used for big data and real-time web apps. For example, companies like Twitter, Facebook, and Google, as they collect terabytes of user data every single day. NoSQL database system encompasses a wide range of database technologies that can store structured, semi-structured, unstructured, and polymorphic data. It provides scalability, availability, and fault tolerance, and that's why it is an alternative for relational database. In NoSQL, the data structures used are key value, column, graph, or document, which makes some operations faster. So here you can see the SQL database structures, and below you can see non-SQL database. Column family, graph, document, key value are the non-SQL database types. As we have seen in the diagram, there are 4 types of non-SQL database: key value pair database, column database, graphs database, document database. The first type of database is key value paired database. They have a dictionary data structure that consists of a set of objects that represent fields of data. Each object is assigned a unique key. To retrieve data stored in a particular object, you need to use a specific key. In turn, you get the value, that is the data which you want, assigned to the key. This value can be a number or a string or even another set of key value pairs. For example, Redis, Dynamo, React. This is a representation of a key value pair database. Here, using this key, you can retrieve any value. The next type of database is column database. In this column database, data is stored and grouped into separately stored columns instead of rows. Such databases organize information into columns that function similarly to tables in relational databases. These are widely used to manage data warehouses, business intelligence, CRM, library card catalogs. Example of this column database are HBase, Cassandra, HBase Hypertable. This is a representation of column database. The first representation is of row oriented and the second representation is column oriented. So as we can see here, data is stored and grouped into separately stored columns instead of rows. Next database is graph database. Graph databases are usually use flexible graphical representation to manage data. These graphs consist of 2 elements. First is node, second is edges. Nodes are used for storing data entities. Edges are used for storing the relationship between entities. These relationships between entities allow data to be stored to be linked together directly and in many cases retrieved with one operation. Nodes and edges have defined properties which by using you can query data easily. Every node and edge has a unique identifier. Each graph-based database mostly used for social networks, logistics, spatial data. Example of this graph database are Neo4j, Infinite Graph, OrentDB, FlockDB. This is a representation of graph database. This circular represents the entities and this arrow represents the relationship. That is the edges. This edges store the relation between the entities. The fourth type of database is document database. This consists of set of key value pairs stored in a document. These documents are basic units of data which can also group into collections, that is databases, based on their functionality. You can easily store data without implementing a schema. You can transfer the object model directly into a document using several different formats. The commonly used are JSON, BSON, and XML. It is mostly used for CMS systems, blogging platforms, real-time analytics, and e-commerce applications. Examples of this document database are Amazon SimpleDB, CouchDB, MongoDB, React, Lotus Notes, MongoDB. This is a representation of document database. Here it consists of, so this documents consist of key value pairs, and you can easily store data without implementing a schema. Some of the features of this NoSQL database are NoSQL database never follow the relational model, as we know that NoSQL is a non-relational database management system. It never provides tables with flat fixed column records. It works with self-contained aggregates or blobs. Doesn't require object relational mapping and data normalization. NoSQL databases are either schema-free or have relaxed schemas. They do not require any sort of definition of the schema of the data, offers heterogeneous structures of data in the same domain, offers easy-to-use interfaces for storage and querying data provided. Multiple NoSQL databases can be executed in a distributed fashion. Advantages of this NoSQL database are NoSQL databases don't need a dedicated high-performance server. They support key developer languages and platforms. It is simple to implement than using RDBMS. It can serve as a primary data source for online applications, handles big data which manages data velocity, variety, volume, and complexity. It eliminates the need for a specific caching layer to store data, offers a flexible schema design which can easily be altered without downtime or service disruption. There are some more advantages of this NoSQL database. It can be used as primary or analytical source. It has a big data capability, no single point of failure. It is an easy replication. There is no need for separate caching layer. It provides fast performance and horizontal scalability. It can handle structured, semi-structured, and unstructured data with equal effect. Object-oriented programming, which is easy to use and flexible. Here are some disadvantages of NoSQL database. It has no standardization rules, limited query capabilities. RDBMS databases and tools are comparatively mature. It does not offer any traditional database capabilities like consistency when multiple transactions are performed simultaneously. When the column of data increases, it is difficult to maintain the unique values as keys become difficult. Doesn't work as well with the relational data since it is a non-relational database. The learning curve is stiff for new developers. Open source options are not so popular for these enterprises. So there are some of the companies which are using this non-SQL are Google, Adobe, Facebook, LinkedIn, Mozilla, Foursquare. This was all about NoSQL. Thank you.
Okay, nice presentation. Who is next? Wait.
Yeah, it's me, Mantachi.
Prachi, start your presentation.
Is my screen visible to all?
No.
Prachi, not visible your screen.
Yeah, is it visible now?
Yes, yes.
So, talk about topics is first, what is data mining, how data mining works, what is goals of data mining, example of data mining, and key takeaways, and the last is application of data mining. So let's talk about what is data mining. So data mining is the process used by a company to turn raw data into useful information. And by using the software to look for the patterns in large batches of data, businesses can learn more about their customers to develop more effective marketing strategy, increase sales, and decrease costs. Data mining depend on effective data collection, warehousing, and computer processing. Data mining process are used to build machine learning models that power application include search engine technology and website recommendation process. I would like to give an example of a data mining is like if you are going on a browser and you are searching for the mobile phone. So the search of your searching of your content is stored somewhere back in a backend. And if you go in a next time on a browser and the pattern is stored in a backend. So related to the last search, you will get a pop-up of a mobile phone on your tab. So it helps to the software as a service process, software as a service companies to increase their sales and customers and increase their business. So what is data mining? Data mining is the process. I think I covered that. So how data mining works? Data mining involves exploring and analyzing large block of information to gain meaningful patterns and trends. It can be useful in a variety of ways such as database marketing, risk management, fraud detection, spam email filtering, or even to discern the sentiment or opinion of a user. Next is the data mining process breaks down into a 5 steps. First, organization, collection data and load it into their data warehouses. Next, they store and manage the data either on in-house servers or a cloud. Business analyst, list management teams and information technology professional access the data and determine how they want to organize it. Then application software stores data based on users result, and finally the end user presents the data in an easy to share format such as a graph or tables. So what is the goals of data mining? First is prediction. Determine how certain attributes will behave in a future. For example, in given period, how much sales volume a store will generate. So next is identification. Identification pattern in a data. Identify a pattern in a data. For example, higher middle class families spend more money buying furniture. So next is classification. In classification, like partition data into a classes. For example, customer can classify it into a different behavior in a shopping. I would like to give an example, like if you are buying shoes with the socks, it like this pattern will happen. So if you are searching for these shoes, related to the searches of socks will pop up on your tab. The next goal is optimization. Optimization, the use of limited resources such as time, space, money, or materials. For example, to maximize profit, how to use the best advertising. So let's talk about the example of data mining. Grocery stores are well-known user of a data mining technique. Many supermarkets offer free loyalty card to customers that give them access to reduce the price not available to non-members. The cards make it easy to store it, track who is buying what when they are buying it, and at what price. After analyzing the data, store can then use this data to offer customers coupons targeted to their buying habits, and decides when to put this item on a sale or when to sell them at a full price. So next example is data mining can be a cause for a concern when a company uses only selected information which is not representative of overall sample group to prove a certain hypothesis. So the key takeaways. Data mining is the process of analyzing large batches of information to discern trends and a pattern. Data mining can be used by a corporate for everything from learning about what customers are interested in or what want to buy to fraud detection and spam filtering. Data mining process breaks down patterns and connected in a data based on what information user request or provide. Application of data mining is one of the application is identify theft. Identify theft occurs when someone tells your personal information, which can include your name, social security number, bank account number, and credit card information. Often throughout data mining, the goal of the thieves is to use your personal information to assume your identity to access your bank account and drain funds. Open and use credit cards in your name. Take out loans. Use your health insurance to pay medical bills and file tax return to collect your refund. I would like to give an example of like a bike theft. There could be one application which will collect or collaborate the information about the theft. Is that if basically the focusing on the creating and deploying a collaborator which will help maintaining and tracking traffic related criminal record with the help of sequence pattern data mining as well as clustering for frequent pattern matching data mining techniques. So related to the which will found in a similar event for a past or used to predict the criminal of a vehicle. So it will be helpful for the traffic police to find the criminal in a better way instead of using the traditional method. So thank you. That's it from my side.
Okay, Praji, good, nice presentation. But I want to tell you that whenever you prepared any presentation now, so only points should be there, not any theoretical things should be there, because you have to only a presentation means what it is the flow, and in this flow what content you are going to deliver. So only mention the small statement, okay, and you have to elaborate through your presentation. That is called the presentations, okay. So next time, whenever you prepare your presentation, only mention the points and you have to describe all these things in details. Okay, no issue. This is the practice sessions because of this activity is nothing but what that already said, improvement in yourself regarding the presentations, regarding the communications, regarding your confidence level. So no issue. Very good. So who is next?
Ma'am, I am the next.
Pagaria, Payal.
Yes, yes. Is my audio is am I audible?
So why the peoples are leaving this meetings? They are not interested, but this attendance is very important because this will reflect your marks. Whenever I consider finalize your marks, that times I will consider this attendance who has attended this session, because this is not for me. This is for you peoples. But if you are not taking it seriously, then it will almost reflect in your internal marks. Okay, start with.
Is my video is visible?
Yes, visible.
Okay. Hello everyone. My name is Payal. I will be explaining you the JSON overview, data types and objects, and how the objects are created in it. So in JSON, in computing JavaScript object notation, or JSON is an open standard file format that uses human readable text to transmit data objects consisting of attribute value pairs and array data types. It is a very common data format used for asynchronous browser and server communication, including as replacement for XML in some Ajax style systems. JSON is a language independent data format. It was derived from JavaScript, but as of 2017, many programming languages include code to generate the path JSON format data. The official internet media type for JSON is application /JSON. .json file names used to extension .json. Douglas Crockford originally specified the JSON format in early 2000s. To computing standards RFC 7159 and ECMA 404 define it in 2013. The ECMA standard describes only the allowed syntax, whereas the RFC covers some security and interoperability the consideration. The uses of JSON. JSON is used in a JavaScript-based application created for web-related features. The data transfer between a server and web application is done by JSON. Over the network, the structured data can be serialized and transferred through JSON. JSON format is used by web services and APIs to provide public data. Most modern programming languages use JSON. Characteristics. It is lightweight, text-based interchange format. JSON is easy to read and write. JSON is a language independent. The syntax for JSON is the data is in the name value pairs. Data is separated by commas and curly braces hold objects. This is the given example for it, where I created an object, variable, my object, and I created entities in it. This is the key and this is the value for it. The data types and objects. The number is the first data type in JSON. The number is a double precision floating point format. Octal and hexadecimal formats are not used in it. And no nan or infinity is used in number. The syntax is as given, where JSON object name is equal to string is equal to number value. The number cannot be enclosed in quotation marks. This is the example. Boolean. It includes the true or false values. The object value object. I have created an object here where this project submitted key holds the value true, which is the Boolean type. The string. It is a sequence of 0 or more Unicode characters. String values is enclosed within quotation marks. Characters is a single character string, that is a string with a length 1. The syntax is as given, and the example is like this, but you have to specify the string in quotation marks, whereas the number does not need the quotation marks. The array. It is a group of elements. The array elements are separated by comma and are enclosed in square brackets. The values are separated by comma. Array indexing can be started at 0 or 1. This is the example for the array, where this is enclosed inside the square brackets and all the key value pairs are enclosed in curly brackets. Object. An unordered collection of a name and value pairs where the names are strings. Since the objects are intended to represent associative arrays, it is recommended through not required that each key is unique within an object. Objects are delimited with the curly brackets and use commas to separate each pair. While within each pair, the colon character separates the key or the name from its values. The syntax is as per given. Here you can see I have created different data types here. This is the number and this is the string type. So the object holds different data types in it. The null, an empty value using the word null. This is the program I have created. Here I've declared the two objects, which is my obj and x. Here I've created the object my obj and declared some values in it, where it contains the keys industrial electronics, graph theory, operating system, and visual basics. And all the values are specified after the colon on the right hand side. Here I have assigned the my object dot operating system to x, which is that it means that you can access the object values by using dot notation. Here I have assigned the value of operating system in x, and now I have the for the print I have used this syntax where it can print the value. Now I will show what x holds. The x will hold the value of operating system, which is 1000. This is the output for it. JSON parse. When receiving data from web server, the data is always a string. Parse the data with JSON.parse and the data becomes the JavaScript object. JSON PHP. A common use of JSON is to read data from web server and display the data in web page. PHP has some built-in functions to handle JSON. Objects in PHP can be converted into JSON by using PHP function, JSON encode. Thank you.
Okay. Who is next? Nice presentation. Who is next? Piyush.
Yes, ma'am. I'm next.
Okay, start your presentation. Atharva is there? Atharva Sarda? Atharva?
Yes, ma'am.
Okay, are you
I
ready?
suppose my screen is visible and I'm audible.
Yes, ma'am.
Okay. Yes, yes.
Okay. Good morning, everyone. The topic for today's activity is mobile databases and SQLite databases. So, what is mobile databases? Mobile databases are separate from main databases and can easily be transported to various places. Even though they are not connected to the main database, they can still communicate with the database to share and exchange data. A database that is portable and physically separate from the corporate database server. Many applications require the ability to download information from an information repository and operate on this information even when out of range or disconnected. Example, contacts and calendars on phone. A mobile database is a database that can be connected to by a mobile computing devices over a mobile network. It can also be defined as a system with the structural and functional properties, wireless and wired communication capability. Ability of mobile database. Communicate with centralized database server through modes such as wireless or internet access. Replicate data on centralized database server and mobile device. Synchronize data on centralized database server and mobile device. Capture data from various sources such as internet. Manage or analyze data on the mobile device. Create customized mobile application. Here is an example of client server mobile database. Advantages and disadvantages of mobile database. Advantages. The data in the database can be accessed from anywhere using a mobile database. It provides wireless database access. The database systems are synchronized using mobile databases and multiple users can access the data with seamless delivery process. Mobile database require very little support and maintenance. The mobile database can be synchronized with multiple devices such as mobiles, computer devices, laptops, etc. There are certain disadvantages. The mobile data is less secure than data that is stored in a conventional stationary database. This presents a security hazard. The mobile unit that houses a mobile database may frequently lose power because of limited battery. This should not lead to loss of data in database. Mobile database architecture, that is MDS. For any mobile architecture, things to be considered are: users are not attached to a fixed geographical location, mobile computing devices, that is low power, low cost, portable, wireless networks, mobile computing constraints. This architecture is built on personal communication system, that is PCS, and global system for mobile communication, that is GSM. Mobile databases is a distributed multi-database client server system. MDS, that is MDS. MDS consists of three hosts, that is fixed host, mobile host, and base station controller. Fixed host means fixed host perform the transaction and data management functions with the help of database server. Mobile host, mobile host. Mobile units are portable computers that move around a geographical region that includes the network that these units use to communicate to base stations. Base station controller are two-way radios. Installation is fixed installations in fixed locations that pass communication with the mobile units to and from the fixed host. Here is the example. When a mobile unit leaves a cell serviced by a particular base station, that station apparently transfers the responsibility for the mobile unit transaction and data support to whichever base station covers the mobile unit's new location. Here are certain here is a host, that is fixed host, DBS, that is the database, MU means mobile unit, BS is base station. Here is an example of it. Existing mobile databases. There are some examples of existing databases, that is Berkeley DB, Couchbase Lite, Level DB, SQLite, UNQ-Lite. Need of mobile database. Need for data to be collected as it happens. Business today means anything, anytime, anywhere, any device. Mobile users must be able to work without a wireless connection due to poor. Mobile servers may be able to work without a wireless connection due to poor or even not existent connections. Need to access data while the mobile user is connected from the network, that is wireless or otherwise. This capability is best implemented by incorporating persistent data storage using a mobile database in your application. Features of mobile database. Provide relational database service but require little memory. Analyze and manipulate data on a mobile device. Handle SQL queries on a road. User can choose to work online with a central DBMS server. Download data and work on them. Capture real-time data and synchronize later. Are customized for mobile application. Here is the example of mobile databases. This is a key, there are key features that are used in mobile databases. Applications of mobile databases. There are three main applications, that is business, public sector, health sector. So what is business? It is so how applications are used in business for information on customers, competitors, and market trends. Salesperson can update sales and customer data on the move. Public sector. US Army uses mobile database technology to get current inventory and read lines info that can save them logistical cost. Health sector. Used by physicians to store and retrieve information while making their rounds. Used by doctors and paramedics to retrieve vital patient history and treatment info while attending to patients in battlefield and remote accident locations. So now I switch to SQLite. What is SQLite? SQLite is a public domain software package that provides a relational database management system, or RDBMS, that is relational database management system. Relational database systems are used to store user-defined records in large tables. In addition to data storage and management, a database engine can process complex query commands that combine data from multiple tables to generate reports and data summarize. SQLite is a lightweight when it comes to setup complexity, administrative overhead, and resource usage. SQLite is remarkably feasible in both where it can run and how it can be used. Let's have a look at some of the roles SQLite is designed to fill. Some of these roles are similar to this taken by traditional client-server RDBMS products. Other roles take advantage of SQLite size and ease of use, offering solution you might not consider with a full client-server database. SQLite is capable of creating databases that are held entirely in memory. This is extremely useful for creating small temporary database that requires no permanent storage. So here is the example, that is traditional client-server architecture and SQLite serviceless architecture. Traditional database are based on client-service architecture database. Database files are not directly accessed by client application but via a database server. SQLite takes a different approach. There is no server involved in SQLite's architecture. The entire database, all tables, indices, triggers, views, is stored in single file. By eliminating the server, SQLite eliminates complexity. There is no need for multitasking or inter-process communication. Support from OS. SQLite only requires read or write to some storage. History of SQLite. SQLite was designed by D. Richard Hip in spring 2000 while working for General Dynamics on contracts with the United States Navy. Hip was designing software used for damage control system aboard guided missile destroyers, which originally used HPUS with the IBMS Informix database backend. The design goals of SQLite were to allow the program to be operated without installing a database management system or requiring a database administrator. He based the syntax of semantics on those of PostgreSQL 6.5. In August 2000, version 1 of SQLite was released, with storage based on GDBM, that is GNU Database Manager. SQLite 3.0, partially founded by America Online, added international manifest typing and other major improvements. SQLite is one of four formats recommended for long-term storage of data sets, approved for use by the Library of Congress. Features of SQLite. Transactions are atomic, consistent, isolated, and durable. ACID. Even after system crashes and power failures. Zero configuration, no setup or administration needed. Full-featured SQL implementation with advanced capabilities like partial indices, indices on expression, JSON, common table expressions, and window functions. A complete database is stored in a single cross-platform disk file. Great for use as an application file format. Support terabyte size database and gigabyte size strings and blobs. Small code footprint, less than 600 KIB fully configured or much less with an optional features omitted. Simply easy to use API. Fast. In some cases, SQLite is faster than direct file system. Input-output written in ANSI. TCL binding included bindings for dozens of other languages available separately. Well-commented source code with 100% branch test coverage. Available as a single NSI source code file that is easy to compile and hence is easy to add into a large project. Self-contained, no external dependencies. Cross-platform, Android, BSD, iOS, Linux, Mac, Solaris, VxWorks and Windows, that is Win32, WinCE, WinRT are supported out of the box. Easy to port to other systems. Sources are in public domain, used for any purpose. Comes with a standalone command line interface, that is CLI, client, that can be used to administer SQLite database. Thank you.
Okay, Shubham. Well, informations you had shared. Okay.
Thank you, ma'am.
Yes, yes. Still, again, same suggestions. Whenever you create your presentations, only points should be there, and you have to elaborate. Actually, whenever we give the presentation, means deliver the lecture contents, that times what happens? We create the word file. Why we create the word file? Because same things we will provide you as a notes. That's why we give all the details. Okay, so that is not the proper presentations, because whenever you create any presentations on any topics, only the point should be considerable. Okay, so no issue. Who is the next one?
Okay, ma'am.
Yes, ma'am. Atharva.
Okay, which is your topic?
Hadoop, ma'am. Can I begin?
Yes, yes, start.
Can someone please confirm, is my screen visible and am I audible?
Yes.
Yes, you're audible.
Okay, thank you. So let's begin. Good noon, everyone. This is myself, Atharva Sada, and today I am going to present you a presentation on Hadoop. What is Hadoop, and everything will be covered. all about Hadoop. The title, yes, the backbone of big data. Yes, you heard correct. It is the backbone of big data. I have included contents like what is Hadoop, its background, how it came into existence, its history, advantages and disadvantages, Hadoop architecture, its description, and the important part, dealing with massive datasets. So let's begin with a basic introduction. What is Hadoop? Hadoop is an Apache-based open source framework implemented in Java, which supports the processing and storage of extremely large sets of data ranging from gigabytes to petabytes. It is the most well-known technology used for big data. Hadoop has very strong processing power and ability to handle virtually unlimited parallel tasks. Hadoop has quickly emerged as a foundation for big data processing tasks like scientific analytics of data, planning of business and scales, and processing enormous volumes of data. Now, friends, in this slide, one thing you may have observed that I have highlighted some points and they all are related to data, such as big data, large sets of data, enormous volumes of data, gigabytes to petabytes. Now, what I mean by this? What do we mean by data? And most importantly, what is big data? Till now, we learn concepts like data warehousing, databases, data mining, and many more. But what do you mean by big data? Can someone please answer? Okay, so no problem. So let's look at the statistics from the time when I started this presentation, that is hardly a couple of minutes ago. Do you know how much data is created? So let's look at it. By the time when I started this presentation, that is hardly a couple of minutes ago, more than 245,000 Facebook posts were created, more than Twitter handled more than 350,000 of tweets, and the most important, which leads in this list, is Google, which handled more than 4 million searches. And yeah, also in the last 2 minutes, more than 51,000 apps were downloaded. Can you just imagine how big is this data? Isn't it surprising? Now, carefully read the next slide and just try to imagine how much data is created. This is the data these websites or social media sites creates per minute, where Google leads in this list with 3.8 million searches per minute. And startups like Uber also gets 2000 plus rides booked per minute. Isn't this a huge data? And now it is here when Hadoop comes into picture. So basically, what is Hadoop? So we came to know that this much data is created per minute. So we can imagine, or even we can't imagine, how much data is created per hour or per day. And in month or a year, well, it is beyond the limits. So something is required to store this data, as we use this data for processing. And Hadoop is nothing but a tool which is used to store this data. So again, let's begin with introduction to Hadoop. I hope the basic idea of Hadoop has been clear in everyone's mind. So let's begin with the history of Hadoop. In 2008, Hadoop defeated the supercomputers and became the fastest system on the planet for sorting terabytes of data. It all started in the year 2002 with the Apache Nudge project. Docketing and Mike Caffarella were working on Apache Nudge project that aimed at building a web search engine that will crawl and index websites. Meanwhile, in 2003, Google released a search paper on Google Distributed File System, which is known as GFS, which describes the architecture for GFS that provides an idea for storing large data sets in a distributed environment. And finally, the day came in the February 2006, where the developers came out of Nudge and formed an independent sub-project called Hadoop. These are the two gentlemen who developed the Hadoop technology. Well, we know, as we saw, it started as a Nudge and then matured as an Apache project. The naming system is quite funny. Cutting was dog cutting. The developer of Hadoop was finding some name to give to this technology, but unfortunately, he was unable to find it. So one day when he went home, he just saw his child he was playing with his elephant, and when he asked what it is, he told that it is Hadoop. So on that point, dog cutting decided that it will name it on its son's stuffed elephant as Hadoop. Later on, cutting joined Yahoo, but Michael continued. The Nudge project further got divided into two parts, that is Nudge and Hadoop. Nudge handles web crawler portion, whereas Hadoop contains distributed computing and processing. Now, let's look at the advantages of Hadoop, why it is so famous and why everyone is using it, and most importantly, why it is called as the backbone of big data. High amounts of any kind of data can be stored and processed quickly. Computing power. Hadoop's distributed computing model processes big data fast. As today, as before some slides, we saw how much data is created. So the main advantage of Hadoop is it handles this data. Fault tolerance. In case of failure of any node, the tasks are automatically redirected to other nodes. What happens is if we are working with a system and suddenly some power cut happens or some cyber attack happens, so there is a risk of reducing our data or losing our data. What Hadoop does is it suddenly redirects the data from our node to the other node, that is the other system. It is one of the best advantage of Hadoop. So by this way, we don't lose any data. The next is flexibility. Flexibility is it handles any kind of data in it, whether it be structured, that is in table form, or it is unstructured, like text, images, and videos. A good example of unstructured data is if we went on some e-commerce website or some apps and we give them review, they already know what their product is and they have sorted data in the backend, but they don't know what the users will give in the reviews. And nowadays we can also add some screenshots, add a short video, and also our thoughts on it in the reviews. So it is considered as unstructured data as it is containing text, images, and videos. Low cost. As it is open source framework, it is free to all. So there is nothing like it is too costly or anything. Scalability. New nodes can be easily added to handle big tasks. If organization thinks that the manpower of the organization is reducing and they want to add some new members to it, they can easily add to the administration department. Well, as every coin has two sides, there is also a darker side on Hadoop. Let's look at some disadvantages of Hadoop. Hadoop is rough in manner because the software is under active development. As it produces many updates, so sometimes it is very much rough in use. Programming model is very restrictive. Joins of multiple data sets are tricky and slow, which causes delay in our work. Cluster management is hard. In the cluster operations like debugging, distributing, software, collection log, etc. are so much hard. It requires care and may limit scaling. Also, it requires regular maintenance of the system. Now let's look at the architecture of Hadoop. This image shows the basic architecture of Hadoop. It contains four modules, namely common utilities, YARN framework, HDFS, and MapReduce. Let's look at one by one and get the concept clear. Common utilities. What are common utilities? Common utilities are also known as Hadoop Common. So common utilities are basically the Java libraries and utilities which are required by the other modules of the architecture to work. The other modules means the three modules, which is YARN framework, HDFS, and the MapReduce. Now, basically, what it does is it provides the Java files, scripts, and information by which we can coordinate the Hadoop. The Hadoop can work internally well. Also, it is most important in maintaining the performance of Hadoop. Well, here maintaining the performance means is when we install a software or when we begin to use a new app, what we think is it should work properly. We should start it and it should end properly. So it is used to start and stop the Hadoop smoothly. It is one of the main feature of common utilities. Moving forward, the next module is YAN framework. YAN stands for yet another resource negotiator. YAN is responsible for performing two operations, that is JS and RM. JS stands for job scheduling, whereas RS stands for resource management. Job scheduling is the method of distributing the big data in smaller parts so the data can run smoothly. What happens is we divide it in small modules so that it can work faster. Also, sometimes it checks the priority to which job should be executed at what speed, and also which job should be executed first. The next is RS, the resource management. The main task of resource management is to collect resources for processing the data, for storing the data. Now, data is created, data is collected, but it must have some resource. As we saw, data is collected from various sites, data is collected from various resources. So for processing, we require some resources. So maintain, manage, and provide the resources is the work of resource management. This is the framework of YAN. Here, the resource manager takes data from the client. So the clients have the resources and it provides to the nodes further. It provides to the mini nodes and then the nodes provide it to get the output. The next module is HDFS. HDFS stands for Hadoop Distributed File System. It is based on the Google file system. As it is of distributed nature, we can keep its replicas too. See, what do we mean by file system? That it is used to store files. But here it is not just a file system. It is a Hadoop distributed file system. So we can distribute the Hadoop data and store it as we want. Also, we can keep its replicas too, such as by some, unfortunately, if we lost some data. So the data replicas can also be kept in the Hadoop so that after losing the data, we can use it replicas. It increases the access of our data. And lastly, distributed storage is its most important part. Let's look at what do we mean by distributed storage. If a data is inserted of suppose 612 MB, so it is distributed in 4 to 5 different parts as shown in these images. This is the working of HDFS. The next technique is MapReduce. MapReduce is somewhat similar to YAN framework and based on it. The major difference in it is the distributed processing and also is that the parallel processing. First of all, let's look at what is serial processing and what is parallel processing. In this image on the left side, we can see it is the serial processing, and on the right side, we can say it is parallel processing. Now, sometime we may have wondered how Google works so fast, how Google provides so much results in very much minor seconds. So it uses parallel programming. What its parallel programming does is it gives the input to all the systems like is shown in this second figure. Program is given to CPU1, CPU, all the CPU, that is task 1, task 2 and task 3, and they combinedly gives us the result. But contrast on contrast, the serial processing doesn't work in this way. In serial processing, the task is given one by one and then the result is also given one by one. So this is the major advantage of parallel processing, and thus we use parallel processing in our MapReduce. MapReduce is divided into two phases according to its name, map and reduce. Let's look more information on it. Dealing with massive datasets. MapReduce is the technique used to deal with the massive datasets. It is subdivided into two parts, map and reduce. As per the name, map function gets executed first and then it is followed by the reduce function. Now, what does basically map and reduce both functions do? Let's understand it by a simple image. Here we can see the data is given to map. Map takes all the data as input and basically it converts it from one form of data to another, which consists of keys and values. Further, keys and values. Now, when it collects the data and breaks it into individual element of data set of input data, and it is broken into small tuples which consist of a key and value. And here the tuples which consist of key and value is the output of this map function, and further it is given to reduce. Now Reduce function takes the tuples as the input to it. It combines all the tuples together on the basis of the values of the keys and make it a set of tuple. Let assume we are given the input this all together, that is one the last tuple we can see it concatenated tuple is the input given to the reduce from map. So what does map does is it distributes it in two groups and then combines all the tuples together and gives us the final output. This is how the map reduce technique works. And when we deal with massive data sets, we use map reduce technique as it is also using the parallel processing. For the map reduce framework consists of single master job tracker and many slave master task tracker. Now there must be someone to give the orders and the others follow it. Isn't it happen? Isn't it? It also happens with us many times. The staff in our college gives us work and we follow it. Well, joke apart, master job tracker. The tasks under master are as follows. It managing the resources. It manages the resources. It manages the data. Which data should be given to whom to produce outputs? Tracking consumption and availability of resources. Scheduling the jobs component tasks on the slaves. Monitoring the tasks and re-executing the failed tasks. Well, the main duty of the is monitoring the tasks. If some task got failed, then it rechecks it and produces the correct output. The slave task tracker. It executes the tasks as per the directions of the master and provide task status information to the master periodically. The job tracker is very important in Hadoop. Map reduce service. If job tracker goes down, all running tasks get halted. So we can say that it is the most important part, and if it crashes, the Hadoop doesn't work at all. Thank you. Any questions?
Any questions regarding Hadoop?
No, ma'am.
Okay. So all of you, nice presentation, nice all contents you have shared with all the students. So thank you. Keep it up this spirit of delivering the contents and spread your knowledge. So we will stop here. Now in next week, I will take your as per previous discussions. I will conduct one or two more lectures regarding the remedial classes, as well as I display the schedule for project presentation. So what is the aim of these project presentations? Means I will check what is the status of your project. Your project is too small, then I will guide you to more need more features or input regarding the project. So that's where I will provide you the guidelines. So in the final presentations, there is not any problems regarding your project. So only the few student attending these sessions. So inform to your student that carefully prepare your project presentations. Okay, now we will stop here. Thank you. You can leave the meeting.
Thank you, ma'am.
Thank you, ma'am.